work on between now and Tuesday. So an example of a problem from R.1. What is R.1? It talks about graphs and equations and models. There is really nothing much, definitely not more than what we already covered here. But I like to look at a problem with interest compounded n times a year. Interest compounded n times per year. And I'm looking at problem 29 on 11. Here's the formula from the algebra part of the previous course. A equals P 1 plus R over N raised to NT. And let me tell you what everything represents. A is the accumulated value. P is the principal. T is time in years. R is the annual interest rate. One more time. A is the accumulated value. P is the principal. N is the number of times we compound interest per year. T is the time in years. R is the annual interest rate. And now N, the number of times the interest is compounded per year. N can be 12 months. In other words, N equals 12. It can be 52 weeks. It can be quarterly. It can be semi-annually. Yes?
I know homework, the M wasn't present at all. I don't think.
Lowercase n?
The N.
This is n.
Oh,
I'm sorry.
okay.
N. So n, and the way I write it at m is this. So this is m and this is m. I'm sorry about that. It doesn't matter. If you want to use m, you can. But normally we use n for the number of times the interest is compounded per year. So n, number of times interest is compounded per year. And now let's see how we handle this. Southside Investments purchases 100,000 certificate of deposit. So I'm just going to copy the numbers and you'll tell me what they represent. At 2.8%. Correct, very good. That definitely is R, which has to be changed into 0.028, mandatory. A decimal number. Good. Let's read on. How much is the investment worth at the end of 1 year? So T equals 1 year. If interest is compounded, part A, annually, how much is N for annually? Good. B, semi-annually. Very, very good. C, quarterly.
1.
Perfect. N equals 4. D, daily. It says use 365. E, hourly. So we have 365 days multiplied by, yes.
87.60.
Thank you very much. Perfect. We don't have to do all of them, but since we wrote them, let's, okay. So first of all, what does 100,000 represent? Very good. So here's our formula that we are going to put in the graphing calculator. P principal, 100,000, parentheses, 1 plus 0.028 divided by x. Why x? Because I don't have n in the graphing calculator. And everything raised to nt. But since t is 1, I will only have x. This is n, this is n. And I'm going to plug it in. I'm not going to repeat the calculation 5 times. I'm just going to put this function in the graphing calculator and change x first to 1, then to 2, then to 4, then to 365, and then to this. So in y equals, here it is, in y equals, let's plug in. I just did that problem with my calculus class. So 100,000, parentheses, 1 plus 0.028 divided by x. Here's x. Let me know if this is okay so far. We didn't finish. And we have to put the power, and I always put parentheses around the power. So 100,000 plus 1 point r divided by n, everything raised to n times t, but t is 1. So that's why I only put n, or x in this case. The next step in your graphing calculator, do we have the function already? Do we have the function in? Okay, then I would like you to go to second and table set. Second and table set. And make sure that your independent variable, just the independent variable, is in the ask mode. Just the independent. Go scroll down, highlight ask, press enter. Are we okay? I'll come and help if you need help. Are we okay? So we have the independent variable in the ask mode. And now we go to second and table. Second and table. What do I want to put in? 1. Then 2. Then yes. Then 365. Then 365 times 24. So then go to the right, go back up, because we need cents as well. And they don't appear here. So for 1, I get 102,800. Then for 2, I get 102,819.60. Scroll down. 102,828.29.54. So let's write them down. So then this, A of 1, A of 2, A of 4, A of 365, and then A of 8760. Any questions? Would you be comfortable solving this problem in my math lab now? Yes? Okay, so the numbers were 102,800. The next one, what was it? 102,800 and 1960. The next one, 102,829.54. 2 more. 102,839.46. And the last one, 102,839.56. The reason why I created this function is because I didn't want to repeat the calculation 4 times. So we created the function, we put it in. This was our n. I don't have n in the calculator. This is our n. If the time were 2 years or 4 years, I would have had 5 or 2 or 3, 5x. Any questions on this? Any questions? If you find when you do your homework anything that you would like to address in class, please take a picture of that problem and bring it to class. Okay. I'd like to move on with this, we already did this. We already graphed. I finally found the piecewise defined function there on page 23. Okay, so let's look at another difference quotient, or do you think that we are okay with a difference quotient? On page 22, let's look at the quadratic function. Let's look at 22. On page 22. We're given a function, and we're asked to find the difference quotient. Another practice, a much easier problem. The previous one was a rational function. This is quadratic. So they want us to find different things. They want us to find the g of -3, g of 0, g of -1, g of 7, which we can do immediately with a calculator, but they also want us to find g of v and g of a plus h, and then they want us to find g of a plus h minus g of a over h. For the first part, I'm going to go back to the graphing calculator and plug in x squared plus 4 and determine each and every one of them in a blink, except the last two. Of course, I can plug it in. So let's go back to g, y equals, clear whatever you have, and let's plunge in x squared. This is x. This key is x. And the squared power is this. So we put x squared. And then plus 4, I think. Yes. Again, go back to second and table now. And let's plug in -3 and 0. There is no need to do this with a graphing calculator, really. But I just wanted to get those numbers quickly. So then the first answer is 13. The second one, of course, it's 4. The next one is 5. And the last one, g of 7, is 53. So I'm sure we don't have any problems with that. We use the exact same idea. But now when it comes to g of v, I just want to draw your attention to how to read any function. So what does this function tell me? Here's what the function is telling me. It says this. This is what the function is telling me. It says you can apply it to whatever, as long as you calculate it or perform the operation or the pattern of whatever squared plus 4. So now if I'm asked to find g of v, all I have to do is whatever plus 4, because now whatever is v. So what will you tell me to write? V squared plus 4. That's it. What about the g of a plus h? This time, the pattern does not change for anything. But this time, the whatever is how much? It's a plus h. So can anyone dictate what to write? Yes. Very good. But now from last Thursday, we know that this binomial squared is how many terms? 3. Exactly. Please don't forget that. Put it on your notebook. So this is a squared plus 2ah plus h squared and plus 4. Finally, they're asking us to determine this. We've seen this before. How is it called? the difference quotient. It's just that it has a instead of x, but it's the difference quotient. So I'm going to copy this piece, which is this, a squared plus 2ah plus h squared plus 4 minus g of a now, please. What is g of a? Same thing. The pattern is right there. Whatever now is a. So what do I write? Yes, but I have to distribute. Perfect, but I have to distribute. Or put in parentheses. Or I write this. Before we proceed, because we identified that this is the difference quotient, what are the two things that must happen here before I even look at it?
Get your move h.
All terms without h from the top must go away. And the second step, h from the denominator must go away. Awesome. If that doesn't happen, I made an error somewhere. Okay. Do the terms without h go away?
Is that supposed to be -4 at the end?
Yes, because I have to distribute -1. So let's write g of a on the side, which is a squared plus 4, but minus g of a gets, the negative sign gets distributed to both. That's okay. I should have put parentheses first and show you the next step. My apologies. So these two go away, and these two go away. So all terms without h must go away. It's a bonus if some of the terms with h go away too. It's possible. But definitely those without h must go away. Now what do you think I need to do next? Very good. Because this h from the top will eventually remove the h from the denominator. So how many terms are left? And I have to write two terms then.
2ah plus h squared.
But I removed the h.
2a plus h.
Very good. So the simplified form is this. They didn't tell us, but we know it's a difference quotient for this function. Between which points? Between the point with x being a and the point with a plus h, a little bit to the right of a, or it could be negative to the left of a. Yes, Ryan?
So that's the slope between those two lines.
That's the slope between those 2 points.
Those 2 points. Yeah.
Yes, the point with P with x being a, and the point Q with x being a plus h. Exactly. That's the difference quotient and the rate of change between those two and the slope of the line between those two, the secant line. So I consider R.1 and R.2 completed. So I'm hoping that between now and Tuesday, you are going to